This current game fragment class is a lot like the house that I was building at the start of the lesson. Much like when I was trying to fit a bathroom and a kitchen in my one large room design, I'm trying to fit a lot of unrelated functionality into my one game fragment class. So, for example, I've got the logic for navigating, calculating score, and all of the code for updating the user interface all in that one fragment. If I start adding new features that require saving data locally to a file or communicating with the internet, I could conceivably put all of this code in the game fragment class, but this would result in a bloated class that's doing all sorts of different functions. Then there's the configuration change issue. Because fragments get destroyed and rebuilt on rotation, they are not a particularly safe place to have all of this data, because the data also gets destroyed along with the fragment. Now, using onsaved instant state is a reasonable solution to this problem, but onsaved instant state bundles have their own issues. They require extra code to store the state in the bundle and then the logic to retrieve that state, and they're also meant to be kept pretty small, well below 100 kilobytes. Store too much data and you risk throwing an exception. These are the types of problems that application architecture and the lifecycle library are meant to solve. Application architecture is a way of designing your app's classes and the relationship between them such that the codebase is more organized, performant in particular scenarios, and easier to work with. Much like how architecting a house helps us divide up and plan out different types of rooms that do different things, architecting an app lets you do the same with code and classes. There's no one right way to architect an application, much like there's no empirically right way to architect a house. Let's look at an example. Here's a home in the architectural Cape Cod style. It's built with steep roofs to withstand the cold winters and a fireplace and chimney to keep the house toasty. Now here's a home architected in the prairie style, which is an architectural style popularized by Frank Lloyd Wright, known for minimalistic designs with open floor plans, lots of light, and use of natural materials. And here's Osaka Castle. As you can see from the moat and the tall stone foundation, this home has been designed to be very good at defending against sieges. So as seen, architecture is heavily dependent on your circumstance, needs, and taste. As with houses, there are many different architectural styles for Android apps, each with different strengths and weaknesses. Some of these styles may even overlap. They fit different application needs, team sizes, team dynamics, and more. If you're interested in different architectural styles in Android, you should check out the Architecture Blueprints repository on GitHub. This repository has the same application, a to-do app, designed using a bunch of different architectural styles. It also has this handy samples at a glance information, which gives you a brief overview of some of the differences between these styles. Now, I can't teach you all of these different architectural styles in a single lesson, but if you do want to dive further, there are many excellent talks, blog posts, and books on the topic. I've linked a few in the instructor notes. For this lesson, you're going to be learning about a single multi-purpose architectural pattern that we're going to build on for the rest of this course. It's loosely based off of an architecture called MVVM, which is Model View, View Model. The reason I'm choosing this style is because it's officially endorsed by Google and it leverages the lifecycle classes.